Okay, so we're going to solve this matrix using Gaussian elimination. So I already took the coefficients from the equations and put them into the matrix for x, y, and z. Since there's no z in this equation, I'm going to write a 0 here. All of the constants are going to go on the right-hand side of my matrix. So there's three things I can do to solve this. I can multiply a row by a constant. So I see right away how the second row has some numbers that can be multiplied by 1/3, and those can be reduced nicely. So the first thing I'm going to do is I'm going to multiply row 2 by 1/3. Because I want to get the left-hand side of this matrix into RREF form. And what that looks like is it looks like this form. So I want to get the first row to be 1, 0, 0, the second row 0, 1, 0, and the third row 0, 0, 1. So that's the whole goal of Gaussian elimination. So when I multiply row 2 by 1/3, I'm going to get the 0, 1, 0 that I'm looking for. So I'm not changing row 1, and I'm not changing row 3. When I multiply by a third, 1/3 times 0 is 0. 1/3 times 3 is 1. And 1/3 times 0 is 0. 1/3 of 12 is 4. Okay, now I'm going to work my way down the first column. I want 1, 0, 0. I need a 0 here. I can't multiply a row by a 0. I'm only allowed to multiply a row by a non-zero number. But what I can do is I can multiply a row by a number and add it to another row. So to get a 0 here, I want to add a -1. So I'm going to multiply row 1 by -1 and add to row 3. So I'm changing row 3 this time. So the other two rows are going to stay the same. So I recopy those rows just like I had them. And now here I'm going to multiply row 1 by -1 and add to row 3. So multiplying 1 times -1, that's -1. Add 1, you get 0. -1 times -1 is 1.